Hello everyone, welcome to another video. We're going to be learning about conditional repetition. So today we're going to talk about what a loop is, what an iteration is, and we're going to learn our very first loop called the while loop. So before we talk about what a while loop is, I want you to imagine this task. Imagine that you're given this task of what are the factors of 144. And we're going to be solving this using by a loop, and we're going to look at how it would be very difficult to do and very annoying to do if we didn't know how to. So, what are loops? Loops are a programming feature to repeat a block of code. So, there are some use cases. Sometimes the solution is reached by building upon a smaller version of the code. Sometimes we need to continuously repeat a block of code or mundane code so that we can get to the final solution. And lastly, loops help us repeat certain code, which helps us generate algorithms. So if we were to look at the factors of 144, one of the solutions can be we can check all the numbers starting at 1 all the way up to 144 and see if 144 is divisible by that said number. If it's true, as in if that number is divisible, then it is a fact. If not, it is not a fact. So if we were to do this without repetition, we would need some sort of 144 lines of code starting at 1, going all the way up to 144, and doing a modulus operation. It would take a while. It would actually be very painful to write. However, if we were to use a loop, we can repeat a certain block of code that we are interested in and continuously update a variable that we are using, and we can check. And we can find all the factors for 144. So in this case, I have a variable set as divider, and it's set to 1. And the number I'm interested in is 144. I'm going to say, well, while this variable is less than or equal to my number variable, I'm going to repeat my block of code inside. We can denote a code block by indenting for certain code statement, like a while statement, and an if statement where it had its own code block. So a while statement is going to run this code block until this condition evaluates false. So we're going to go if num modulus divider is equal to 0, as in divider is a factor of num. We're going to output that value. On every iteration now, or every loop, we're going to increase this variable called divider by 1 so that we can end that condition, or we can make that condition false so that we can end the loop. So we were able to do this. So what are iterations? Iterations is the act of repeating a mathematical or computational process. We iterate so that we can generate unbounded sequences of outcomes, or we want to approach a desired goal, target, or result. So in terms of terminology, we can say that each repeated step in an iteration is also called an iteration. Such result from the previous iteration will be used for the next iteration. The reason I have that sentence there is that sometimes your textbooks will explain iterations like so, and it becomes very repetitive. Another thing I wanted to highlight is that in the context of mathematics or computer science, iteration along with related techniques, something called recursion, which we look at in another course, is a standard building block of algorithms. So the reason why we use iteration is mainly to create algorithms. So let's talk about iterations in Python first. There are numerous ways to implement iterations in Python. The one that we're learning right now is while loops. The next we're going to learn is for loops. And in a future course, we're going to learn another iteration technique called recursion. So we often use a loop term to label iteration. For this course, at no point should you be using the keyword break within your code. One of the first things I do when I mark your assignment is that I'm going to look for break, and if found, I'm going to mark that assignment 0. The reason is that for beginner programmers, they rely on break too much to exit their loop, and they don't construct their loops properly. They don't construct their Boolean conditions for your while loop properly. So I do recommend that all beginner programmers don't use break until they are fully understanding and capable of writing proper while loop. So let's talk about while loop. How a while loop works is that first we will be going through with their code, and we're going to hit a condition. As long as that condition is true, we're going to execute the code for that condition. And we're going to go back. If the condition still holds true, we're going to execute the code, and on and on and on until that condition becomes false and we can continue on with their code. And I hope that by now you might be realizing that if the condition never turns false, we will be stuck in something called an infinite loop, which we'll be talking later. In Python, we can write a while loop like so. We can use a keyword while, write a Boolean expression that either values to true or false, and we can write whatever block code or Python code that you want to execute inside the while. So a while loop is a condition-based iteration that repeats this block of code if and only if its Boolean expression is true. And it also supports nesting. Nesting means that we can have a while loop inside a while loop. So what's a code block? I want you to recall that code block is a group of code that belongs to a certain component or a statement in your program. So this block here belongs to this if statement. This block here belongs to this elif. This block belongs to this else. And we talked about this when we learned conditional. So while loop, it only executes its code if the Boolean condition is true. So let's examine this code here. We're going to say, well, while our num is less than 100. So right now, our variable num is 3, so this is true. Then it's going to execute this code, come back, and check it again with this new value. As long as it's true, it's going to execute all this and check again. So once we continuously loop through and execute these code, there will be a time in this code where num is either equal to or greater than 100. That will make its Boolean condition false. That's when we don't execute these code blocks anymore and move on with the rest of our code. There are something called infinite while loops. It's just a loop that never terminates because the Boolean condition never turned false. It was always true. Therefore, it kept on executing this block of code, and it's very bad practice to write such loops in your program. So when do we use while loops? We use while loops when you're unsure when the end criteria is. Like you don't know how many times you need to run a certain block of code, so you just use a while loop based on a condition, and hopefully it turns false so that you end your loop, right? Or you use a while loop when the user determines when to end your program. So you can ask them a question and grab a value by input, and based on that value, you can stop the iteration, right? Or there are multiple conditions that are required for the block to execute, and as long as that condition is true, we can continuously execute our code. And sometimes, in very rare cases, we do need an infinite loop. A very good example is when we create a game. For example, if you're running a 60 FPS game, it is 16 frames per second kind of game. It is running the infinite loop or the loop's code block 60 times per second. We're executing some sort of game code. But basically, if you were to ask yourself, do I know when to start and end the program with 100% certainty? If not, you can use a while. There's also a Python specific format, which is called the while else loop. Basically, it works much like an if else. If you recall that if something is true, we execute the code block. If the condition was false, we execute the else block. Same idea here. While this condition is true, we're going to execute the code inside. However, if that condition is false, we jump to the else state and execute the else state. In Python, this isn't really a necessary thing to do, but if you were to see this on a future textbook or a future when you go on Stack Overflow, I did want to show you what that would look like. So let's look at some while loop example. So here's a problem. We want to create a program such that given a positive integer n, the program will print its factor. We're not going to be dealing with any decimal numbers, and factors are numbers that we use to multiply to get another number. So for example, 4 has factors of 1, 2, and 4. So let's look at a while loop solution. First, we're going to grab a user input, and then we're going to have a variable called factor of 1. So I'm interested in factors, and I'm going to be manipulating this variable, and as long as that variable is a factor, I'm going to output that result. Here, we're just going to write a little base case such that if the user input was 1, I don't want to do any intensive work. So we're going to say the factor is 1 because there are 4 factors. Otherwise, so user input wasn't 1, and we know that we're only dealing with positive integers, user input must be greater than 2. We're going to say, well, while our factor variable, it doesn't equal to user input plus 1, we're going to say, hey, if the user input modulus of the factor variable is equal to 0, then that factor variable is a perfect factor for our input. So we're going to output the factors are blank. Then on every iteration, I'm increasing this variable called factors by 1. So in this case, if I were to be interested in the number 12, factor will start at 1, and it will become 2 on the next iteration, then 3, then 4, then 5, then 6, 7, then 8, then 9, then 10, then 11, then 12, right? Then it will check 12, and it will become 13. Therefore, factor is not equal to user plus equal 1 anymore. I mean, the factor is equal to user plus 1 now. So this statement becomes false, and we now get to end our loop. So we get to loop through this 12 times so that we can find the factors of 12 if that was true. So to end this video off, here's a challenge to you. I want you to create a while loop so that you can solve this problem. You're going to create a program that adds up all the values from 1 to n. I'm going to say that let n be a user inputted value of a natural number greater than 1. You're to create a program that adds up all the numbers from 1 to n. Thank you for watching. Stay classy.